So last class, we talked a little bit about matrices. We started with what is a matrice, and we defined the size of the matrix based on the number of rows and columns, and we found the position of each one. So R1, C1 would be 1 because it's on row 1, column 1. We also talked about our row operations, how we can operate on matrices. We can switch any two rows. We can multiply a scalar number by a row. And we can also add any two rows together, but we can also multiply a scalar to one of the rows and then add the two rows together. The third thing we talked about was setting up a system of equations into an augmented matrix. So we took this system and set it up into a matrix. So we're going to do that again today, but we're going to solve using Gaussian elimination. So with Gaussian elimination, the final matrix we want to get to is 1 down the diagonals, 0 in the lower left triangle, and all these pound signs can be any number they want to be once we operate on them. So let's start looking at an example first before we get into the steps. I like doing an example, then get to the steps and doing more examples. So first, let's set this up into an augmented matrix. And if you remember from last class, we're just going to take all the coefficients in the solutions column and set up a matrix. So I have 1, 2, 3, and then my solutions column will give me 4. Excuse me. And then my second row, I have 1, 3, 5, and 7. In my third row, I have 2, 6, 7, and 5. Now, what do you think I want to do based on the solution? What do you think I want to do first to get to this matrix? Okay, getting a 1s down the diagonals. That's important. I would say get this 1 first. If I get a 1 on these two, then I'm still going to operate on these two rows, and it's going to change those 1s. So let's get this 1 first, which we already have. So check. So since we still got to operate on these rows before we get these 1s, let's get these two positions to a 0. Now, how can I get this to 0? And remember, let's use our row operations. How do you think I can do that? Correct. If we multiply -1 times row 1 and then add row 2, that goes to a 0. So that's what I'm going to do. And when we do that, that gives us a new row 2. So -1 times row 1, what does that give us? -1, -2, -3, -4. And what I'm really going to do is multiply a +1 times row 2, so that doesn't change the row. So 1, 3, 5, and 7. Now add these together to get 0, 1, 2, and 3. Now what about this position? What do you think I can do here? Okay, I could multiply -2 to row 2, but remember row 2 changed. Think about what column you're in. You're in column 1, so let's use row 1. And that's going to be a thing in the future. Whatever column you're in, you want to use that row to get that position to 0. So since we're in column 1, let's use row 1. So what can I multiply to row 1 and then add row 2 to get that to 0? And that would be -2. Correct. Good job. So -2 row 1 plus 1 times row 2, or row 3, I'm sorry. It gives us a new row 3. So if I multiply -1 times, or -2 times row 1, what does that give me? -2, -4, -6, -8. And then 1 times row 3 just gives us row 3. So let's add these really quick. -2 plus 2 is 0. -4 plus 6 is 2. -6 plus 7 is 1. -8 plus 5 is -3. So I'm going to set up my new matrix. We didn't do anything to row 1, so I'm going to keep it the same. We changed row 2 and got 0, 1, 2, 3. And we changed row 3 and got 0, 2, 1, -3. So now the next thing y'all said about getting 1 diagonal, you notice that the 1 here is already in my row 2, column 2. So that's good. I'm getting 1s down my diagonal. Now, what I want to do is I want to get this to a 0. Now, based on what I said earlier, what do you think I can do? Correct, we're in column 2, so we want to use row 2. And so we want to see what we can multiply to this 1 to add to this to get to 0. And correct, that's -2. So we're going to do -2 row 2 plus 1 times row 3 to give us a new row 3. So let's do the -2 row 2. That gives us 0, -2, -4, -6. And then row 3 is 0, 2, 1, -3. And then we're going to add these. This gives us 0, 0, -3, -9. And that's our new row 3. So when I set up my matrix, I have 1, 2, 3, 4. I'm sorry, let me scoot that up a little bit. The 0, 1, 2, 3 from the previous row 2. And then I have 0, 0, -3, -9 for my row 3. Now I want to get this to a 1. How can I get that to a 1? Correct, scalar multiplication by a -1/3. So I want to do -1/3 row 3. And that gives me 0, 0, 1, 3. And that's my new row. So when I set up my new matrix, I get 1, 2, 3, 4, 0, 1, 2, 3, and then 0, 0, 1, 3. Now we got our 1s down our diagonals. We get the 0s in the bottom left triangle. That means we have got to the solution matrix in a sense. We still need to do one thing since we don't have what X, Y, and Z are technically are yet. What do you think we can do to find X, Y, and Z? Okay, we're going to set these back up into a system of equations. So I'm going to do them by the row. So row 1, my coefficient to X is 1. So I've got 1X. My coefficient to Y is 2. My coefficient to Z is 3. So I'm just setting this back up. I'm going back from a matrix to a system of equations. So second row is Y plus 2Z equals 3. And my third row is Z equals 3. So I already have Z. That's great. Now, that's great. We have that. Now, what do you think we can do with Z equaling 3 to solve for Y and X? Correct. We can substitute Z into row 2. I'm going to call this row 1, row 2, and row 3. We can substitute Z into row 2 and solve for Y. So we can say Y plus 2 times 3 equals 3. So Y plus 6 equals 3. So subtract 6 to each side, we get Y equals -3. So now with us having Y and Z, what do you think we can do? We can substitute that into row 1. So sub Y and Z in row 1 and solve X. So we have X plus 2Y. What we know Y is -3 plus 3Z, but we know Z is 3 equals 4. So now let's solve this. X positive 2 times -3 is -6. 3 times 3 is 9. -6 plus 9 is 3. And then we want to subtract 3 to get X equals 1. Now, when we're talking about these, this is 3 lines. This is a 3-dimensional graph where we have 3 planes intersecting, and when they intersect at a point. So we're going to write this solution in X, Y, Z form. So, because it is a point. So I want to set my X is 1, my Y is -3, and my Z is 3. And that is done there. Now, let's go back through the steps of what we did. We set the system into an augmented matrix. We got row 1, column 1 to 1 by either row swap or scalar multiplication, or if it was already there, we're good. Then we got row 2, column 1 to 0, and row 3, column 1 to 0. Then we got the position in row 2, column 2 to 1. And then we got row 3, column 2 to 0 by multiplying it to row 2 and adding. And then we got row 3, column 3 to 1 by scalar multiple. And then we set up our system of equations based on what we had left, and we solved for X, Y, and Z, and we put our final solution in the form of X, Y, Z. you have any questions